Imagine a world where we never worry about running out of energy again. No blackouts, no carbon emissions, just clean, limitless power flowing from the same force that lights up the stars. Sounds like sci-fi, right? Well, for nearly a century, scientists have been chasing that dream. And now, for the first time in history, it might actually be within reach. This is the story of fusion energy, what it is, why it's so hard, and how it could finally change everything we know about power on Earth. Welcome to Energy of the Future. Will fusion finally power our planet? Let's start with what fusion actually is. You know how the sun burns? It doesn't use fire. It fuses hydrogen atoms together under insane pressure and heat, turning them into helium. In that process, a tiny bit of mass becomes a whole lot of energy. Einstein's famous equation, E equals mc squared, means even a small amount of matter can release an enormous amount of power. If we could recreate that reaction here on Earth, we'd have an energy source that's practically limitless. A single glass of water, yes, water, contains enough hydrogen to power your home for centuries. No joke. No greenhouse gases. No radioactive waste like in nuclear fission. And no risk of a meltdown. Fusion is like the ultimate clean energy cheat code. But there's a catch. To make fusion happen, we need to heat hydrogen to around 100 million degrees Celsius. That's 5 times hotter than the sun's core. At that temperature, matter turns into plasma, a glowing soup of charged particles, and it doesn't like being contained. Imagine trying to hold the sun in a magnetic bottle. That's basically what scientists are doing. The idea of fusion isn't new. In fact, scientists first dreamed of it back in the 1950s. They built giant metal donuts called tokamaks to trap plasma with magnetic fields. But every time they got close, something went wrong. The plasma wobbled, escaped, or cooled too fast. Billions of dollars later, fusion became the running joke of the energy world, always 30 years away, no matter when you ask. Still, progress never stops. Right now, several megaprojects are racing toward the goal. There's ITER in France, a $25 billion international project that aims to produce more energy from fusion than it consumes. It's the largest scientific collaboration on Earth, involving over 30 countries. Then there's NF, the National Ignition Facility in California, where scientists use 192 giant lasers to compress a tiny fuel pellet until it fuses. And in 2022, they finally did it. For the first time ever, they produced more energy from fusion than the laser energy hitting the target. It was a turning point, a moment when fusion crossed from pure theory into practical possibility. So, are we about to flip the fusion switch and say goodbye to fossil fuels? Not quite yet. That laser experiment lasted just a fraction of a second, and the entire setup used hundreds of times more energy than it produced overall. But still, it's proof that the physics works. Meanwhile, private companies have jumped in with fresh ideas. Startups like Commonwealth Fusion Systems, Alion Energy, and Tokamak Energy are designing smaller, faster, cheaper reactors. They're betting on powerful new magnets made from high-temperature superconductors, which can trap plasma more tightly than ever before. Alion even signed a deal with Microsoft, yes, Microsoft, to deliver fusion power to the grid by 2028. Is that overly optimistic? Maybe, but it shows how serious the race has become. The question isn't, can we make fusion work anymore? It's when will we make it work efficiently enough to matter? Let's imagine for a moment that fusion finally succeeds. Every city could have a compact fusion plant, producing power without pollution, fuel pipelines, or geopolitical drama. No oil wars, no gas shortages, no coal smoke. Countries could literally pull hydrogen from seawater and generate electricity for centuries. Fusion could power factories, charge electric cars, and even make clean hydrogen fuel for airplanes and ships. It wouldn't just change the energy system, it would change civilization itself. Energy would become cheap, abundant, and clean. That's not just good news for the planet, it's a total economic reset. Of course, fusion still faces massive technical and financial challenges. We're talking about controlling something hotter than the sun, building materials that can survive it, and scaling reactors safely for daily use. But for the first time, the pieces are coming together: physics, technology, and global willpower. After decades of false starts, fusion's time might finally be near. So the next time you look up at the stars, remember, we're learning to build one right here on Earth. And if we get it right, the light of tomorrow might come not from oil, gas, or coal, but from the same fire that's been burning in the heavens since the dawn of time.